Hello and welcome to Kumas Online Academy. Today we are concluding our discussion on quadratic equation, and we are still talking about quadratic graph, how to solve quadratic equation using the graphical method. So today we are going to learn how to find the root of another quadratic equation using the graph we've drawn for another quadratic equation. That is a very common question in WAEC theories. They will give us one quadratic equation and ask us to find the root of another quadratic equation using the graph we've drawn for the first quadratic equation. Now, I'm going to show you how to do that. Now, take this one as an example. This is actually from past WAEC question. We are given this is the equation given to us, the first one, and we are asked to draw the graph of this quadratic equation, that is y equal to 5 minus 7x minus 6x squared. We are given the values of x minus 3 to 2. Of course, we are also given this inequality. Now, we are not asked to use the graph we've drawn for this one to find the root of y equal to 2 minus 7x minus 6x squared. We have y equal to 5 minus 7x minus 6x squared, and we are asked to use the graph of it to find the root of another equation. The second equation is y equal to 2 minus 7x minus 6x squared. Now, how do we solve this? For us to solve this, we first of all draw the graph for the first equation. In the previous lessons, we've learned how to create the table of values so we can complete this table, as in we can get the values of y using what we learned from the previous lessons. And also, we've learned how to draw the graph, joining all the coordinates between x and y to get the coordinates, and then we trace the curve. A quadratic equation always gives us a parabola, that is a curve, a shape that is curved. So when we draw the quadratic equation, how we are going to get the root for this one, for the second equation, is that we equate this second equation with the first equation. That is, we equate 5x minus 7x minus 6x squared. We equate it to 2 minus 7x minus 6x squared. Now, when we equate it, we equate everything to y, and then we'll be able to get the value of y. We'll get another expression for y. When we get that expression for y, it will always give us one number or a unit, a value, maybe 1, 2, or 3, or 4, or something. Now, when we get the value for the y, we go to the y-axis, locate that value. If it is 3, at the y-axis, we locate 3. If it is 1, at the y-axis, we locate 1. If it is 2, at the y-axis, we locate 2. If it is minus 4, at the y-axis, we locate minus 4. Then we draw a line that will cut the original graph we've drawn before at both sides. Of course, you know that the quadratic equation is always a curve, so it will curve it at the other side and also curve it at the second side. Now, the 2 points where that y line cuts it, we trace it to the x-axis. The value it gives us at the x-axis are the roots of the second equation. Now, watch how I did it. I've actually worked on it just to show you how I did it. Now, this is our table of value. If you solve it, you get these values for y. So I've done this to make this lesson easier for us. So from this table of values, we now draw our graph. Our graph, if we draw it, we are going to get something like this. This is not accurate because I sketched the curve. I don't actually use a normal graph, so just a sketch. This red curve is the original curve for y equal to 5 minus 7x minus 6x squared. That is the original equation given to us. Now, see, to get the root of the second equation, we equate the first equation with the second equation. That is this. We now say 5y equal to 5 minus 7x minus 6x squared, and that is equal to, equate it to the second one, which is 2 minus 7x minus 6x squared. Now, when we equate it like that, now we bring all the terms to one side. That means that y now is equal to 5 minus 7x minus 6x squared. Now bringing this one to this side, now it becomes minus, this is minus 2 then plus 7x plus 6x squared. This one has minus here. It is coming to this side, becomes plus, and the second one also has minus. It also becomes plus. 2 has plus, coming to that side, it becomes minus. Now, we cancel the ones that are like. We have minus 7x and we have plus 7x, so the balance will give 0. We have minus 6x squared and we have plus 6x squared. The balance will give 0. So what we are now going to have is 5 minus 2. So we have 5 minus 2, which means that y now is equal to 3. Now what we now do is that we go to the graph, locate 3, and then draw a line from that 3 that will cut the graph at both sides. You draw a line that will cut the graph at both sides. Then you trace the curve to the x-axis. Now, see the line I've drawn. That is this line here. This place, I assume that this place is 3. It's just a guess. This is not accurate. I use a scale of 2 cm to represent 10 units. So it is actually giving me a very tiny margin. And there's no way I can sketch 1, 2, 3. I can get 1, 2, 3 from this. So I just guessed. Make accurate guess. Okay, from this point I now take as 3. I draw this straight line to cut the original graph, that red curve, at both sides. So it cut it here. It cuts it, okay, it cuts it here and also cuts it this place. So these 2 points that it cuts it, we trace it down to the x-axis. We trace this one down to x-axis, and then we trace this one also down to the x-axis. Okay, now the points of this line at the x-axis are the root of the second equation. Now still trying to make accurate guess from this. This, I will take it as a 1.4. I can say 1.4 for this one, minus 1.4 at this side, and then at this side I can say, let me say 0.2. This is 1. I'm taking 2 units, 2 cm to represent 1 unit at the x-axis. So this place is, I can take it as 0.2. So that becomes the root of the x-axis. This is a sketch. a freehand sketch. Now in the normal graph drawn, the normal graph shows that x is equal to 0 is equal to minus 1.45. If the graph is drawn very well, you get minus 1.45 and you get another value as 0.25, which means that this my sketch is very accurate. I got tracing it down here. I'm just looking at 0.1 minus 1.4 and 0.2, while the original or the accurate value is minus 1.45 and 0.25. So that is how to draw it. If you have your graph paper, you can draw the graph to confirm the actual values for it. Note that the scale you use when drawing a graph does not affect the true answer you are going to get. It does not affect the roots that you are going to get. It will just help you to have enough balance to read your values. It does not affect the values you are going to get. So whether you are using 1 cm to represent 1 unit, or you are using 2 cm to represent 1 unit, the answer, if you draw your graph very well, will still get the same thing. Only that if you choose your scale very well, you will have enough space to read your scale, to read your values very well. But if you choose numbers that are too tiny, you may not be able to trace your values accurately. So that's just the essence of choosing the right scale. It does not affect the actual value you are going to get. But sometimes if you choose the one that are not too good, you will find it very difficult to read your values. So that is how to do this. I hope it is very clear. Now, one thing I want to chip in again is this. Sometimes they will give us another graph and ask us to use the same scale we've drawn for the first one to draw another graph. Within the same graph, we are drawing another graph. It is very simple. It may be another quadratic equation. You draw a table for that one and draw the same graph for this. Sometimes they will ask you to find the root of that one from the first equation. You also find the place where the two curves join and trace to the x-axis. This one, we have to equate the two values, the two equations, to get y-axis. In some other equations, they can give us different values that we can use to draw another graph. And when we draw it, then we look for the place where the two curves join and trace it to the x-axis, so we can get our root for that second equation. Or sometimes it may not just be for us to get the root, they may just want us to draw the two curves in the same graph sheet. They will not ask us to get the root of anything. We just leave it like that, and that is how to solve that one. So when you see it, if you are given two equations and you have different values to draw the two graphs, you can now do it. And if you are asked to find the root of it, you can also do it by looking for the place of intersection between the two graphs and trace to the x-axis to get your values. Okay, meanwhile, this is how to do this one. To solve the root of y equal to 2 minus 7x minus 6x squared using the graph of y equal to 5 minus 7x minus 6x squared. It is very simple and very easy. I hope you really understood it. Thank you.